Hi guys, welcome to the second week of graphing trig functions. So last week I taught you guys how to graph sine and cosine, and I gave you the transformations, vertical and horizontal stretches, compressions, as well as reflections. So we actually did a bulk of the work last week, and the reason for that is really I just wanted to give you guys another week of practicing this stuff. So this week all I'm doing is I'm adding in, moving the points left, right, up, down. So this week is going to be all transformations. So we're going to label all your transformation rules for a sine function and for a cosine function, even though they're pretty much the same thing. But anyways, all right, so an a value out front. So if you have an a value, this is a vertical stretch or compression. And that's what it tells you your amplitude. If you have a negative out front, if there's a negative out front, that means you flip over the x-axis. And then so a value was last week, and then b value. We also did the b value last week. If there's a b value out front, that is a horizontal stretch or compression. And the b value helps define period. Helps define period. So remember the period of these is 2 pi over b. All right, and so this week we're adding in if you have the x minus h plus the k. So remember, if it's with the x, it's the opposite. So if you have minus h, you move it right h. If you have plus h, you move it left h. And then plus k, that moves it up, down. So if it's plus k, you move it up. If it's minus k, you move it down. And so these are all of our transformation rules that we've done a million times. So remember, all that's different is technically that the a value tells you your amplitude, and the b value helps you find the period. They don't just like directly relate to like moving it on the graph at all. You have to do a little bit more work. And so cosine's the same thing. So a is amplitude. If it's negative, it's reflected. B helps find the period. Remember, the b value isn't the period. It helps find the period. Helps find period. 2 pi over b. Minus h, this moves it left, right. Plus k on the outside moves it up, down. So these are our transformation rules. So just like our other transformation rules, we're just going to plot the points like we did last week and then just move them up, right, left, down. I said that weird. Up or down, left or right if we need to. So we're going to graph like normally and then use the vertical horizontal shifts to move them if you need to. So we're going to graph completely normally. So that means, you guys, you're going to kind of have like two graphs. And this happens a lot when we graph with our transformation rules. This is something like every time we graph like polynomials, or we saw this a lot with graphing square roots and cube roots. We'd plot our 3 points and then we would move them, you know, left 2, up 6 or something. So then some of you guys like to erase the old graph, or tell you like circle it or point to the one that's your final answer or whatever you guys want. I just switch colors. If you want to do that, that's fine. So I'm going to graph the original graphs in blue, and then, I don't know, pick a different color that you guys can see. Red. I'll put my final answer in red, sure. So we're going to go through and find all the information like normal. So the only weird thing is, if you notice, the b value is the number and it's outside the parentheses. So that's the only thing that looks weird this week. Last week, sometimes you'd have like sine of 6x, and there would be no parentheses. Or it would be sine of 6x with parentheses. And this was your b value. Now, because we're adding that other transformation in, it's always going to be chilling outside the parentheses. So it's cosine 2 of the inside part or whatever. So labeling information. So let's try some of these. So this is your amplitude. So your amplitude is 3. Your b value is 2, so that means the period is 2 pi over 2. Your 2's cancel, so the period is pi. So that means you're going to complete one cycle in 0 to pi. So 0 to pi, one cycle. And it's a cosine cycle, so remember that starts high. And then this is saying move all your points if it's plus pi. So remember, plus means you're going to move it left. So remember, it's the opposite of what we think when it's on the inside. So this means move your points left pi, and -1 on the outside means move it down 1. So we're going to do these transformations first. So we're going to do that first, and I'm going to plot that. And then in red, I'll move the points left pi, down 1. All right. So the first thing we do is to graph cosine, you start high. So I'm going to label, I didn't label the axes because sometimes, depending on the amplitude. So I'm going to label this 3. This is -3. So that means cosine starts high. So cosine's going to start up here at 3 because the amplitude's 3. And then one cycle happens in 0 to pi. So cosine starts high and ends high. So at pi, we're going to have another 3. Halfway between cosine is the minimum, so the low point. So these are your high points, your maximums. Halfway between 0 and pi is pi over 2. You can also count boxes, right? Like you have from here to here, halfway is here. So that's where your -3 is going to occur. And then halfway between each of those is going to be your 0 points. So halfway between here and here is here, and that's going to be the 0, the 0. All right, so our one cycle of cosine looks like this. And remember, all I'm asking you guys to do is graph one cycle. All right, so this is what we did last week. So we graphed the amplitude, the period. It's a cosine graph, so it starts high and ends high. And then now all we need to do is take these points and move them left a value of pi and down 1. So a pi value is 1, 2, 3, 4 boxes. So we're going to move all of our points. So left pi, and then it changes depending on the graph, right? So it just happens that pi from 0 to pi is 4 boxes. So this means we're going to move them left 4 boxes, and then down 1, you just move them down 1 box. So move all your points left 4 boxes and down 1 box. So this point will be 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. All right, and here's your one cycle of pi now. So one thing I want to talk to you guys about is this thing called a midline. And so I'm going to add some information back up at the top. So far, before our transformations occurred, your graph was always centered around 0. And so this is called the midline because it's equidistant to the top and to the bottom from the midline, which is based on your amplitude. The amplitude is 3, so you can go up 3 boxes, down 3 boxes. And that's always from 0 so far because we haven't moved anything up or down. But now that we've moved things up or down, your midline is no longer here at 0. It's actually been shifted down 1. And so your midline lives here now. To go up 3 boxes and down 3 boxes, your midline is at -1. Midline is at -1. So how do you think things changed, or how do you think the midline became -1? Well, it's because we shifted it down 1. And so back up here, your K value, the K value is your midline. And so that's another vocab piece. So your K value determines your midline. And so before we were adding or subtracting 0, right? We didn't have a midline. We didn't have a K value, so that means that your midline was at 0. And there's actually a handy dandy formula that if you need to find midline, your midline is the maximum value plus the minimum value divided by 2. So if you've been given the equation, great. But if you haven't been given the equation, or you're looking at a graph or something, you can use this trick. And so let's check it out. So here, let's try it with your original. So your maximum is 3, your minimum is 3. -3 plus 3 is 0. divided by 2 is 0. So your midline is 0. But let's try this one. Your maximum value happens at 2. Your minimum value happens at -4. So let's use a calculator. 2 plus -4 divided by 2 is, look at that, -1. So your midline is at -1. So that's something you don't always need. I just wanted to give you guys the midline formula. And the max and the min, you guys, just occurs, the highest point. You oscillate between something always. So the highest you ever go for the final graph is 2. The lowest you ever go is -4. So your maximum values occurs at 2. Your minimum value is -4. So we're going to label all this information for the rest of our graphs. On your quiz, you're going to be asked to do everything that you see here. So we're going to try 3 more. I didn't leave a lot of room for my other examples. I've been drawing so much. All right, so just to recap. So first step is graph like we normally would, and then we'll just move them left, right, up, down. All right, so this one is saying, so first of all, there's negative, so it's been reflected. There's a 2 out front, so that means the amplitude is 2. Your B value is 1/5. So real quick, let's pause. And the period for this one would be 2 pi over 1/5. Keep it, change it, flip it. That's the same thing as 2 pi times 5 over 1. So 2 pi times 5 is 10 pi. So you're going to complete one cycle in 10 pi. So one cycle is going to go from 0 to 10 pi. So we're going to graph that first. So let's just graph one cycle from 0 to 10 pi, amplitude 2, and it's been reflected. So this is a sine function. So sine starts at 0 and ends at 0. So we're going from 0 to 10 pi. So 10 pi is out here. And then sine's halfway point is also 0. Halfway between 0 and 10 is 5. And then sine is usually you make a peak and then a valley, but it's been reflected. So we're going to make a valley and then a peak. Halfway between 0 and 5 is 2.5. So 2 and 3. So 2.5. We're going to go to -2 first. Halfway between 5 and 10 is 7.5. And then to 2. So remember your amplitude's 2. So you're going to go down to up to. And remember, it's a valley then a peak because it's been reflected. So here's one cycle of sine. All right. So this is what we did last week. Now, this week we're going to add in, we're going to move the points. If it's minus, we're going to move them right 2 pi. And 2 pi is 2 boxes. So 2 boxes. And then up 2. So we're going to move them right 2 boxes and up 2, which is, they're 1 box each. So we're going to move all your points right 2, up 2. So right 2, up 2. These ones are decimals, so right 2, up 2. Right 2, 3, 5, 6, right 2, up 2. This one is a decimal, 1, 2, 1, 2. And this one, 1, 2, 1, 2. All right, so we moved our cycle. And we're done. So like I said, I definitely like to use a different color. So now we're going to go through and label where the midline's at. So the midline should be your K value. So our midline should be at 2. It is. So remember, your midline for sine is where your 0 points should occur. It is true. It's also just a halfway point between the graph. So here's your midline. Midline. And then let's label our max and min values. So our maximum occurs at 4. Our minimum down here occurs at 0. Min is 0 of your final graph once you've moved them. All right, let's try a couple more. All right, so here our amplitude, I'm gonna kind of So this one, there's no reflection. Amplitude is 4. Your B value is 1/2. So real quick, let's find the period. So for this one, the period is going to be 2 pi over 1/2. Keep it, change it, flip it. 2 pi over 1 times 2 over 1 is 2 pi times 2 is 4 pi. So the period is 4 pi, so there's one cycle in 0 to 4 pi. So we're going to plot that, and then we'll worry about these. All right, so it's a sine function. Sine starts at 0, ends at 0. So we start at 0, 0, 0, and then we go to 4 pi in one cycle. So one cycle in 0 to 4 pi. Halfway between is 2 pi. And then remember, sine does its peak and then its valley. Now, how high up do we go? Well, the amplitude's 4, so our peak occurs at 4. Our valley occurs at -4. Here's our one cycle for our sine function. So we're almost done. Now we just have to move them. So our other transformations, this is saying to move them, if it's -3 pi, we're going to move them right 3 pi. And this is saying to move it down 2. So the 3 pi is 3 boxes. So 3 pi is 3 boxes. So we're going to move them right 3 boxes, down 2 boxes. Right 3 boxes, down 2 boxes. So I'm going to do this one first. 1, 2, 3, 1, 2. This one. My boxes are so faint. 1, 2, 3, 1, 2. This one. 1, 2, 3, 1, 2. This one. 1, 2, 3, 1, 2. And this one. 1, 2, 3, 1, 2. All right. So here's our cycle. So for our final answer, our midline should be at -2. So this is your midline. So your midline's at -2 here. Boop-a-doop-a-doop. So this is your midline. And your max value is 2. Your min value, -6. All right. Let's try one more. Negative cosine 4 of x plus pi minus 3. All right, so first of all, there's a reflection. So this for this problem. So there's a reflection. The A value, if there's no number out front, the A value is just 1. So the amplitude is 1. And then your B value is 4. So your period, 2 pi over 4, that reduces to pi over 2. Oh, wow. All right, so we're going to complete one cosine cycle in pi over 2. So one cycle from 0 to pi over 2. So something's going to be really skinny. All right, so let's plot one cycle, 0 to pi over 2. Okay, so cosine normally starts high, but it's been reflected, so it's actually going to start low. And the amplitude is only 1. So -1, 1. So this one's going to be kind of small. All right. So cosine starts low now because of the reflection. So it starts low, and it's going to end low at pi over 2. And that means the midpoint is the high point. And the amplitude's only 1, so we start at -1, and the high point's going to be at 1. And then halfway, so it's going to be little decimals, are the zeros. And so here's your little baby cosine graph. There's one cosine cycle. Yay. All right, and then your transformation rules are saying move it left pi. Pi is 1, 2, 3, 4 boxes. So move them left 4 boxes and then down 3. And that's going to be your midline. So let's move them left 4, down 3. 1, 2, 3, 4, 1, 2, 3. These are your little half ones, so count halfway between. 1, 2, 3, 4, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. All right, so your little cosine cycle is now down here. Your midline is at -3. Your midline. So your maximum value occurs at, this is -2, and your minimum occurs at -4. So that means you're oscillating between -4, -2, -4, -2, -4, -2, -4, -2 forever. Remember, all I'm having you guys graph is just one cycle. Like I said, they go on infinitely, right? I just don't want to confuse you guys with trying to plot more points. So we're just going to plot one cycle for our functions. All right. So these are our transformation rules for graphing sine and cosine. I think graphing sine and cosine actually looks really cool. I like graphing sine and cosine. All right, so now we're going to work backwards a little bit. My printer doesn't work too well, so I had to sketch these in. So what if we work backwards? What if we have been given a graph and they want us to write the equation? All right, well, the first thing I like to find is the midline and the amplitude. So I'm going to do that first. And so I told you guys that midline is the max plus the min divided by 2. And so that's where this gets really helpful. So your minimum value occurs here at -5. So your min is -5. Your maximum is occurring here at 3. So to find the midline for this one, the midline is -5 plus 3 over 2. All right, calculator. -5 plus 3 divided by 2. All right, your midline is at -1. So I'm going to come put a dotted line in for your midline. Your midline is here at -1. So you also know now your k value. So that's your k value. The k value is -1. All right. And so having the midline is nice because now we can figure out the amplitude. How many boxes up and how many boxes down are we going? So if you start at -1, the max and the min should be the same distance away. So the max is 1, 2, 3, 4 boxes away. The min is 1, 2, 3, 4 boxes away. So if you're going up 4, down 4, that means your amplitude is 4. So that's your A value. And so for these, I'm not going to make you guys graph a phase shift. It's really hard to see phase shifts. So remember, the general function is A sine b of x minus h plus k. For writing the equation, I'm not going to have you guys worry about a phase shift. So these are going to be A sine b of x plus k or A cosine b of x plus k. So there's 3 things we have to find: the a, b, and k value, and then decide if it's sine or cosine. So I always start with finding the k, because midline is easy to help you find amplitude. A value. So last up, we need the b value. And so the b value is tricky. To find the b value, you have to use the period. And so here, we have to decide now, is it sine or cosine? So hopefully we can see that it starts at 0. So if it starts at 0, that means it has to be sine. Starts at 0, has to be sine. Sine starts at 0. So let's figure out how long it takes to have one cycle. So start at 0, here's your peak, here's your valley, and we're done at 8 pi. So the period is 8 pi. And so to find the b value, the period formula, so b, let's do it down here. The period formula, period is 2 pi over the b value. And so to solve for the b value, we literally set the period formula equal to our period. So our period, 2 pi over b, is equal to, in this case, 8 pi. So we have to solve for b. So to do that, I multiply both sides by b. So 2 pi equals 8 pi b. And then to get b by itself, we divide both sides by 8 pi. So the pi's cancel out. 2/8 is the same thing as if you reduce it 1/4. All right, so the b value is 1/4. And that's all we need. The k value, the a value, the b value, and figured out along the way that it's sine. So our function is f of x equals the a value is 4 sine 1/4 x minus 1. So your amplitude sine b value x, because there's an input, and then minus 1, because that's your midline. All right, next up. This one. So like I said, the first step is find your midline. So step 1, find your midline. Your maximum is occurring at 1. So your max is 1. Your min is occurring at -5. So let's do -5 plus 1 over 2. -5 plus 1 divided by 2 is -2. So your midline is -2. So that's your k value. Great. And then I'm going to draw that in. So my midline is here at -2. And then so then we can use the midline to count up and down. So it's 1, 2, 3 up, 1, 2, 3 down. Great. So step 2, your amplitude is 3. Your amplitude is 3, which is your a value. So your amplitude is up 3, down 3, so your amplitude is 3. Sweet. So these are the two easy ones. So we've got the k value, the a value. Now we just have to figure out the period and the b value and all that. So now we have to ask ourselves, when we start, do we start high or at 0? Well, in this one we started high. So if it starts high, that means it's cosine. So it starts on a max, it's a cosine. And so we know that a cosine function starts high and ends high. So we start high, and then it goes down to a low, and then up to a high. So here is one period. So a period here is from 0 to pi. So the period is pi. Well, I know that period is 2 pi over b, and that equals pi in this case. So we need to solve for b. So I multiply both sides by b to get the b into the numerator. 2 pi equals pi b. We're trying to get b by itself, so divide both sides by pi. The pi's cancel, so 2 equals b. Sweet. And we're good. We got the k value, the a value, the b value, and we know it's a cosine. So f of x equals a value, 3, cosine. The b value is 2x, and then the k value is -2. So there's your function. All right, so we've gone back and forth now. We have graphed trig functions with all their transformations, and then we have written the function given a graph. And so the last thing I want to do is show you guys some application problems. Like I told you guys in class, for some of you, there's lots of applications of trig, but I want to show you guys out kind of simple. So we're going to talk about Ferris wheels. Yay. All right, so a Ferris wheel is 60 feet in diameter. So I'm going to make a picture. Let's draw a picture. My blue pen is kind of dying on me. So let's say we have a Ferris wheel. All right, so our Ferris wheel is 60 feet in diameter. So this diameter, the whole thing across, is 60 feet. So diameter is all the way across the circle. It completes a revolution every 80 seconds. So it takes 80 seconds to go once around the circle. So one revolution, so if we start at the bottom, it takes 80 seconds to go around once. So one walk around the circle, kind of like the unit circle, right? One walk around the circle is 80 seconds. Okay? The center of the wheel is 35 feet above the ground. So the middle here is 35 feet above ground. All right. And then let's keep reading. You enter the Ferris wheel from a platform 5 feet off the ground. So you get on a platform and it's 5 feet off the ground. All right, so and you start at the bottom of the wheel. So you're going to write an equation to model the situation. So as you guys know, so there's spots we need to fill in the equation. So we've got a, and then it could be sine or cosine, x, or I guess bx. We're not going to talk about phase shifts because that doesn't make sense, plus k. So if you guys notice, like I don't always, phase shifts are the trickiest. So the moving it left, right, it's called a phase shift. We don't always talk about that. So we need to figure out, first of all, let's talk about if it's a sine or a cosine function. So let's think about it like this. We're starting at the bottom. So when do we start low? If we start low, so it's starting at bottom. If you start at the bottom, that's like starting low. And if you're starting low, that means it's a cosine and it's negative. So I know it's going to be negative something cosine blah. All right. So let's read carefully. So the middle of the wheel is here. So that's going to help us figure out amplitude. So what's the amplitude of the wheel? So if the diameter is 60, so the whole thing is 60. So that means as we wave around, we're going to go up to what and down to what? Basically, we need to know what's the radius, because that's going to be our amplitude. So the amplitude would be 30. So I'm going to fill that in, 30. The A value is 30, because that's the radius, right? If the whole diameter is 60 feet, if we were walking around, so as you wave around, your positive is going to be, it's going positive 30 to negative 30. And then remember, amplitude is absolute value of stuff. So 30 plus 30 equals 60 as a whole. So it's going up to 30, down 30, up 30, down 30 feet. All right. So our A value is 30. Our B value, we have to solve for that. We know that it takes 80 seconds to go around the circle. So that's one full rotation. So that's one cycle. So one cycle, 80 seconds. So that means that the period is 80 seconds. So we have to solve for the B value. So our period is 2 pi over B, and we know that it equals 80. So we got to solve for B. So multiply both sides by B. 2 pi equals 80B. Divide both sides by 80. 2/80ths is the same thing as 1/40th. So B equals 1/40th pi. Awesome. So let's start to fill in some chunks. We have negative 30 cosine of 1/40th pi x. We're getting there. And then we just have to figure out if it's been shifted at all. So your midline is right here, but if you start 5 feet off the ground, it's been shifted how? It's been shifted a direction. Because, you know, a Ferris wheel doesn't start on the ground, right? You have to, like, it's a little bit off the ground so that you can get into it because it's like, you know, gravity. So because the Ferris wheel starts 5 feet off the ground, so there's a couple ways that the 5 feet's working in. Your amplitude is 30, so if it was centered around zero, it would be 30 feet off the ground, right? But your wheel is 35 feet off the ground, and you're 5 feet off the ground, so it's been shifted up how much? 5 feet. So this tells you that it's been shifted up 5 feet, so there's room for you to get on. So the last thing is plus 5. So f of x equals negative 30 cosine 1/40th pi x plus 5. I know, this is a lot. This is your level 4 question this week, and it's very similar to this. So if you want to get the level 4 this week, your question is very similar to this. Very, very similar. So don't worry if you don't understand how to do this. This is your level 4 question on your quiz this week. I just know that if I didn't do one of the level 4 type questions with you guys, you probably weren't going to get this because this is a lot. Normally in class, I spend a couple days on doing trig applications with you guys, and they're really cool. Like, I have a lot of cool space ones. Like, I have a lot of cool star applications and space applications that I really like. I mean, you guys know that I like space. So normally I love to do those. I have some cool tide applications. I have some weather applications. Some really cool stuff that if you're interested in, you do this stuff more in pre-calc too. But I wish I got time to do these with you guys. The Ferris wheel example is the most traditional one because it's easy to visualize. So if you're doing the level 4, make sure you draw yourself a picture. All it really is it's like a unit circle. So the Ferris wheel is like a unit circle. So when you're on the unit circle, usually you start at 0 and go around, right? But in this case, we started at the bottom and walked around. So that's why it's a negative cosine function. If it had started at the side, like up here, and that's some of your homework questions. Some of your homework questions on WAMAP, there's application questions like this, and it asks you to start at the middle of the wheel, and so that would be like a sine function because you're starting at 0. This one, you're starting in the negatives, you're starting at the bottom, so that means it's cosine, it's starting low, so it's negative. So that's how you figure out it's going to be negative cosine, and then you can use that midline, to find the amplitude. So the middle of the wheel, it's 60 feet in diameter, so that means it goes up 30, down 30. So your midline would be at 0, but because it's been shifted up to 35, 5 feet off the ground, you have to shift it up 5. There's a lot that goes into this. I think the trickiest thing is finding the b value, setting the period equal to 2 pi over b, solving for b. But yeah, I think you guys got this. Really, it's really based on if you understood last week, because all we're doing this week is just shifting them left, right, up, down. So let me know if you guys have any questions. I'm always here to help you guys. This is probably, I would argue, the most difficult thing we're going to do all year, this last week and this week, graphing trig functions, mostly because it's just a lot of information to keep track of. So if there's a part of this that you don't understand, I completely get that. This stuff probably looks scarier than it is, but you guys got this. I'm always here for you. Let me know if you have questions. Thanks.